Welcome to Pure Mathematics 1, Chapter 4, Function, topic Inverse Function. So first of all, what's a inverse function? I will make my domain here. And here's my range. I have a function x1 to x1 plus 1, and here's x integer. So if I have here's 0, 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Because my domain run from this one, so 1, my x equal to 1, so my range run from here, my image run from here. 1 to 2, 3, and 3 to 4. But here's here's x, and here's x plus 1. But now I want to reverse my function, which I call the inverse function. Inverse function. I want to change from my image back to my domain. So when I have a new function called inverse function, denoted as f to the power of minus 1. This function would run from x to x minus 1. So why? Why it runs from x to x minus 1? Because at first it runs from x plus 1. In order to go back from here to here, we have to minus 1, right? And x would be integer. And here we can look at the inverse function in this way. A function can be inversed only when this is a 1-to-1 function. Only 1-to-1 function can have the inverse function. Why? If you look at the graph of some function, maybe like this one, here is the graph of this line. I have another graph which is this one here. You can see that with the one values of x, here I have a value of y, another value of x, I have another value of y. This one is called the 1-to-1 function, right? 1-to-1 function. But here, looking for this graph, which is y equals to x squared, I can see that when I have one value of x here, it will be 2, and here's another value, here's minus 2, another value of x, which is 2. We have the same values of y, which is 4 here. And with one value of y, we have two values of x. So this one is not a 1-to-1 function. 1-to-1 function. In order to have the inverse function, we need a 1-to-1 function when we convert the image that we have back to the domain. So we cannot use something that when it converts and it has two possible values, it's not be so appropriate, and then we'll use a 1-to-1 function. But for this form, when we restrict the domain of x, it will be another story. If we restrict the domain here, x, it could belong to the group of all real numbers. But now we restrict x to be in the group of positive real number. So we don't care about this part because it belongs to the real negative number. And we have this one. So from here, when we have one value of x, we still have one value of y. And when we have one value of y, we have one value of x. So this is okay. From this one, we can know that here, if the function equal, this one is x to x squared. So in this case, it would be inverse function of this one would be x to the square root of x. Now we will talk about the graph of the inverse function. The graph of the inverse function. So I have a plane here. Here's y, and here's x. So remember that the rules for the graph of the inverse function. So first of all, we take the line y equal to x. Here's y equal to x. Here's the line y equal to x. So there is one rule that the graph of the inverse function will be reflected through the line y equal to x from the original function. So let me take an example. First I will draw a graph like this one. Yeah. So it is reflected through this line, so it would look something like this. Here, it's the same. They're reflected through this line, and now I have the graph of x to the power 3, which is this one. X to the power 3. Here, y equals to x to the power 3, and now I want to sketch the x 1, 2, x to the power 3. But now we want to have the inverse of x, which is this one, x move to here. And now I want to sketch the graph of y equal to this one. Now I don't want to use the method of taking each value of x and then calculate the value of y and plot them in here and connect them as accurate as possible, because I know the rule that these two are inverse functions of each other and it reflected through the line y equal to x, so I can sketch it really. It's quite accurate here, and down here, and then here. If the red curve and the blue curve are reflected through the line y equal to x. And now we're going to learn how to find the algebraic form of the inverse function of a function. So first of all, I have a function fx equal to 2x plus 7, and then I want to find the inverse function of this one, which is this one. And we have that y equal to 2x plus 7, and the function itself is fx equal to 2x plus 7. And now we do something called interchanging x and y, or you can say that swap x and y. So first of all, you have y equals 2x plus 7. Now you change it into x equals 2y plus 7. You change all the letter x, you change into letter y, and all the letter y will change it into a letter x. And from here, you make the function to the subject of y. So now you have 2y equal to x minus 7. So y equal to x plus 7 over 2. So here will be your inverse function of fx equal to x minus 7 over 2. Right? One more rule that you need to remember: the domain, and here's the range. First of all, the domain have x, and here your range you have 2x plus 7. But now you want to find the inverse function of this one. You will move back to here. So the domain of fx equal to the range of f minus 1x. Because now when it's changed from here, so this one becomes the domain, and this one becomes the range. And another rule is that the range of f x will be equal to the domain of f minus 1x. I have an equation here. Let me take an example. Now we have fx equal to 2x plus 7 with x greater than 5. Okay? And now I have that my domain, and here's my range for fx, and down here for f minus x and 1x. The domain of this one would be x greater than 5, right? And from here I substitute into here, so I work out that the range of fx would be 2 multiplied by 5 plus 7 would be 17. Y greater than or equal to 17. Because the range of fx will be equal to the domain of f minus 1x. So here the domain of this one will be x greater than 17. And here the range would be y greater than or equal to 5. They interchange with each other. Now we are going to solve this question. The function f, only f here is the emoji here, is defined for x belong to real number by f to 4x minus 2x squared. Find inverse function of f and state its domain. So first of all, we'll go and find the inverse function of this one, 4x minus 2x squared. First, we swap x and y. So we have x equal to 4y minus 2y squared. So x equal to minus 2y squared minus 2y, because minus 2y multiplied by minus 2 will be 4y. I add 1 here to complete the square, because minus 2 multiplied by 1 is minus 2. So we need to add 2 here because no constant term in here. So we have x equal to minus 2 y minus 1 squared plus 2. So x minus 2 equal to minus 2 multiplied by y minus 1 squared. So x minus 2 over minus 2 equal to y minus 1 squared. So here y minus 1 equal to square root of x minus 2 over minus 2. So y equal to square root of minus x plus 2 over 2 plus 1. So the inverse function of this one, x equal to square root of minus x plus 2 over 2 plus 1. Here's the inverse function. And we want to find the domain of f minus 1x. So it will be the range of the function fx. So now we go into the range of fx. We have 4x minus 2x squared can be converted to this one. The same method, we have minus 2 multiplied by x minus 1 squared plus 2. You know that for all values of x, this one, x minus 1 squared greater than or equal to 0. So minus 2 multiplied by x minus 1 squared will be smaller than or equal to 0. So this one will be smaller than or equal to 0 plus 2, which is 2. From here, we see that the range of fi will be smaller than or equal to 2. So y will be smaller than or equal to 2. Because the range of fi is y smaller than or equal to 2, so the domain of f minus 1x will be x smaller than 2.